Okay. I'm going to show you quickly the way I'm supposed to teach you how to do this in Math 1. Then I'm going to teach you a different way because I think it is easier. So, if I have a problem, let's just do one for me homework. 2 birds with 1 stone here. All right, let's do number 1. I've got negative x squared minus 2x plus 15. I'm going to graph this up here so you can see it. This is not calculator active, but I think it is helpful to see what it looks like sometimes. So, minus 2x plus 15. All right, and let me hit that button. All right, so if I graph this, all right, on this graph, I have x-intercepts at negative 5 and 0, or negative 5, 0, and 3, 0. Right? And then with a parabola, it's either going to be a sad-face parabola where you have a highest point, a maximum point, or it's going to be a happy-face parabola where you have a minimum point, the lowest point. Right? So you either have a maximum or a minimum for all of these graphs. That is called the vertex. Okay? A vertex is a general term that just means that turning point of the graph, or you can call it the maximum or the minimum that's more specific to that graph. So, just looking at this graph, where would you say that that maximum point falls in relation to my zeros? To those x-intercepts? It's in the middle, right? Because this graph is symmetric, right? If we cut it in half, if I put a line right here at x equals negative 1, if I cut that in half, half of it looks like the other half, right? And so what's going to happen here is wherever your zeros are at, the vertex is going to be halfway between, okay? How do I find the halfway between points, the number that's halfway between? Sometimes you can just kind of know, like halfway between negative 5 and 3 and know what number it is. Like, if I ask you what number is halfway between 1 and 3, what would it be? 2. That one's really easy, right? Sometimes it's not as easy. Negative 5 and 3 is not terrible, but you take an average. So you add them together, divide by 2. That'll work every time. So if I take negative 5 plus 3 and divide that by 2, and you can write this down on this one. This will get this one finished for you here. I've got, that'll be negative 2 over 2, which is negative 1. That is going to be your x-coordinate of the vertex. All right, so for my vertex, I know my x-coordinate is negative 1. Now, if I know my x-coordinate of my vertex, there is a way for me to find the y-coordinate of this vertex. Anybody know what I can do there? Savannah? It is not 15. 15 is our y-intercept, which is right here. This one's slightly higher. I mean, you would not have this to look at to know it's 16, but it's a little bit higher. Here's something kind of cool about functions. Like if I want to know, actually I'm going to call this, instead of calling this y, I'm going to call it f of x. So if I want to know the y-coordinate that goes with something, all I got to do is plug the number in. So like if I want to do, if I want to know what value I get when I plug in negative 1, I just plug negative 1 in, right? Negative 1 is 16. That's going to give me that point right there. I mean, this would work with any point. So like if I do f of 2, and what Desmos is doing is it's just plugging in 2 for me, I get 7. If I graph that point to 7, it's going to be on my graph, right? So if you ever need to know the y-coordinate that goes with any x-coordinate, you just plug it in. is all you do, and it's going to give you the y coordinate out. So this is also helpful, like if you get a problem like this and it's a graphing problem and you have no idea how to do it, you can just plug some numbers in. You can plug in 1 and 2 and 3 and see what you get, and then graph those points, and it will help you for that. So what I can do here to find the y coordinate is I'm going to do y equals negative 1 squared minus 2 times negative 1 plus 15. I will square that negative 1 first, which will give me a positive 1, but this negative outside of the parentheses, it still stays there. Then I've got negative 2 times negative 1, which gives me positive 2 and positive 15. And negative 1 plus 2 is 1, plus 15 is 16. So this is my y coordinate. Of the vertex. So that would be negative 1, 16. And so I want to also go ahead, what I want you guys to do for these problems is I want you to sketch me a little tiny graph of what this looks like. And I want you to label the points. So my x-intercepts are going to be at negative 5 and positive 3. You don't have to like put tick marks there to label, but I do want you to label it like this. This would be 3, 0. This would be negative 5, 0. Those are my x-intercepts. My y-intercept would be at 0, 15, so I could put that here. And I will label that point. And then my vertex is at negative 1, 16, so negative 1, 16 would be just a little bit higher than that y-intercept point. This would be negative 1, 16 right here. And then I'll just trace in my graph for that. This just gives us kind of like a general picture of what this would look like. So, one way to do this is to just find the point halfway between the x-intercepts. For these problems, your vertex will always be halfway between the x-intercepts. Okay? Here's the problem. Sometimes you're going to get these problems and they're not going to ask you for the x-intercept. So if you do this method, you've got to find the x-intercepts first, and then you have to find that point halfway between. Technically, or so they tell me, I am supposed to teach you how to use this method for finding the vertex when you're in Math 1, because you're not going to get any imaginary numbers or anything where this would not work. You should always have zeros. So this should work always. One thing I like about this is it just kind of makes sense. You should sort of think, well, my x-intercepts, the maximum or minimum point is always going to be halfway between. It kind of makes sense for what the graph looks like. So if you like using this method, you are welcome to use it. It is really not any more difficult than the other way I'm going to show you, unless you don't have to find your x-intercepts. However, there is another shortcut sort of method, and this will work even whenever you get to Math 2 and maybe possibly have like problems where you'll get imaginary solutions and stuff like that. You won't see those in Math 1. But this method, although I'm not going to give you imaginary solutions in this class, it'll work even whenever you get to that in Math 2. So, we've already talked about the vertex is the turning point of the parabola. To find the vertex, the first thing that you want to do is put the equation in standard form. Y equals ax squared plus bx plus c. Normally, it's already given to you in that form. This just means you've got it written out where you got the x squared first, then the x term, then the constant term there at the end. Okay. To find the x coordinate, you're going to do negative b over a. And we'll do an example here in a second. So this is your formula for the x coordinate of your vertex. And then just like we did on the last problem, whenever you want to find the y coordinate that goes with that, you just plug that back into the original equation. Okay, so let's look. That may seem a little bit complex because of these variables here, but it's really not. So let's look at a problem. Okay, We're going to find the vertex of y equals x squared minus 5x minus 6. Okay? So, I need a number in front of every term. This x squared does not have a number there, so what number is there, even though it's not written? A 1. All right, so I've got a 1 right here. So that means my a would be 1, my b would be negative 5, and I don't need it, but that last term would be negative 6. So the formula for the x coordinate of the vertex is negative b over a. So if I've got x equals negative b over a, I'm replacing b, so I'm going to take out that b, and I'm replacing it with the number negative 5. Only use the number, don't use the x that goes with it, just the number, just the coefficient. And then the a, I would replace it with the a value, which is 1. So for this problem, negative 5 just gives you a positive 5. 5 divided by 1 is 5. Okay, so that is the x-coordinate of the vertex. To find the y-coordinate of the vertex, you're just plugging that number back in. So y would be 5. I know, it's possessed. Fives do it for some reason. I know. Every time I do a problem, I regret putting the 5 in the problem here. So we'd have 25 minus 25 minus 6. And 25 minus 25 is 0, so we just get negative 6. So we would have our vertex would be negative 6. No, got that backwards. 5, negative 6. The nice thing about this is you don't have to find the zeros first, so if they didn't ask you to find the zeros, you don't have to do it this way. Whereas if we do it the other way, you have to find those x-intercepts, those zeros first, which would be an extra step. Okay, everybody good there? Makes sense. All right, number 2. Let's see, Giancarlo, what is my A value? All right, B value. Good. And we don't really need the C, but it would be negative 5, right? So if we're doing negative B over, hold on just a second. I think I've messed it up. Let's graph this and see it. Oh my, I've just taught you how to do something wrong. I haven't done that in a long time. There was a time in my career where I taught kids to do things wrong. I think I've got my formula wrong on this. Let's see. I can't remember. All right, let's graph this. Is it going to be 5, negative 6? It is not. Oh, my formula's wrong. Okay, I've taught you how to do. Now, what I taught you first was correct. The one we did from the worksheet, we did that correctly. Yes, I am sure on that one. I mean, we can type it in just since I'm losing my mind, but I'm pretty sure. Yeah, I graphed that one. I graphed that one while we were doing it. We're good. That one's definitely right. And finding the middle of the two x-intercepts definitely works. Here is what I have done wrong. And this is terrible. This formula right here.
Well, Aiden said he got it right. I did get it right before you.
Did you do it the other way and you got it right? Just kind of did what we were learning earlier. Okay. Yeah, you can do that. All right. Here, the formula should have a 2a on the bottom, not just an a.
What did you teach us?
I just taught you negative b over a, which is wrong. It's negative b over 2a. All right, let's go back. Let's fix number 1. You need to wipe negative b over 8 out of your mind and replace it with negative b over 2a. If I had, I'm about to reference a movie I don't even know if y'all have seen. If I had one of those blinky things like Men in Black, y'all seen that movie? Okay, good. Okay, all right, good. That makes me feel better. That some of the movies, well, I mean, I know y'all were probably like not even born when they were made. Because I watched them in my teens. So, but it makes me feel good that you guys have seen that though. So we have something in common. Sometimes I reference movies like one day I made a fat guy in a little coat comment. Anybody know where that one comes from? Where's that one? Tommy Boy. Nobody in the whole class knew about Tommy Boy, and then I thought, oh, I'm so old and out of touch with the young people these days. But you guys know Men in Black. So if I had one of those flashy things, I would flash your memory right now and tell you to forget the last 5 minutes where I taught you how to do this wrong. All right. But I don't, so we got to pretend we've got that. So this should be 2 times a right here, which will give us 5 halves or 2.5. And earlier I was searching for my key and I never found it. I am pretty sure I do want us to use calculators on this. So we're going to pause for a second while everybody goes and grabs their calculator. Random one. Somebody taking number 6. Thank you, Caitlin.
What number? 12? Okay. I need number 12. I'm sweating.
It is a little warm in here today. I guess it's warm outside.
Yeah, it's warm outside. And I had actually brought a sweatshirt, and it's supposed to be hot outside.
I hope you have a t-shirt also.
Oh, I don't.
You don't.
I forgot to bring pants. I forgot to bring, layers.
Oh.
So I just have, a sweatshirt and a hoodie.
And no pants. You have to run in jeans.
Oh, I'm not done. I mean, unless I go home and then get what I need and go back.
No, you can go all the way. No, you can go all the way home.
Exactly, so I can't do that.
You better go do some running at home.
I will do that.
Okay, that'll be good. Yeah. All right.
I was just going to do some running. I'm going to quit.
All right. Okay. All right, let's go back and fix this. We should have a 2.5. I am going to let you use your calculator on this part. If you get a calculator you may see these on calculator inactive. What you'll see is they'll be easier numbers, but they're really hard to make up. So a lot of the ones on the worksheet that I have given you are going to give you decimals, so I'm going to let you use the calculator. But if you see it on the test, it's probably not going to be a decimal. So since we get 2.5, let's do 2.5 squared minus 5 times 2.5 minus 6. And then we're just going to use the calculator for that. All right, negative 12.25. So let me fix my vertex. It is wrong. At least I realized that I was teaching you wrong before we did the whole worksheet. Yeah, that would be wrong. It's not. I didn't fix it. I know. I'm slacking. I know. I do. You're right. All right. Okay. All right. So formula should be negative b over 2a, not just a, but 2a. All right, so I need to do that negative b. It's just going to be the opposite sign, right? So if I have a negative 8, it's going to become a positive 8 because I'll have negative 8, right? So it's just going to be the opposite sign. If you want, you can think of that formula as opposite of b over 2a. And then 2 times the a value is 2. So that gives us 8 over 4, which is 2. I would like for you to try to do these without the calculator unless you're getting decimals, because you'll probably see this on you may see this on calculator inactive, and I want us to be able to do it without a calculator if it shows up there. So we'll have 2 times 2 squared minus 8 times 2 minus 5. What do I do first there? Square the 2 first. So that's 2 times 4 minus, you can go ahead and do, that will be 16 minus 5. So you got 8 minus 16 minus 5. So it's negative 8 minus 5 will give us negative 13. So my vertex is 2, negative 13. Here's a question for you. Is that vertex going to be a maximum point or a minimum point? Okay, how do you know it is a minimum, Isabella? Not necessarily. It could still be a maximum. The negative does make us think it probably would be minimum, and it may be the case. Not because it's a low number, but because the x squared. So it's not because it's a low number, but I know that parabolas are either smiley faces or sad faces, right? Which one is this? This is a happy face. Happy faces have a low point, right? That's a minimum. So anytime you have a happy face parabola, this is going to be our minimum here. If I had a sad face parabola, if it opens down, then it's going to be a maximum point. So number 3, is it going to have a maximum or a minimum? It's going to be a sad face, which is going to have a highest point, which is going to be a maximum for that. So you'll have a max. It's kind of backwards sometimes because like negative makes you think low, which is minimum, but the negative makes it sad face, which has a maximum point. All right, so let's do this problem. I need my A is negative 1, my B is 9. I don't really need the C for this, but it would be negative 10 if you do that. So X is going to equal negative B over 2A. That's my formula. So when I plug that in for this one, Caitlin, what will I get? Okay, formula is opposite of B over 2A. What's my B? Good. So we'll have negative 9 over, then we'll have 2. What's my A value, Caitlin? Negative 1. So we put that here. Negative 9 over negative 2. And that is going to give me 4.5. If you get a decimal for this, it is okay with me if you use the calculator to do the next part. You do want to be careful on that calculator. It will lie to you. I'll show you what's going to happen here in a second if you do it. Well, actually, this one you might not mess up, but some of the others you may. So that's our x coordinate. How do I find the y? Plug it back in. So you got negative 4.5 squared plus 9 times 4.5 minus 10. When you type this in, you do want to be careful with parentheses. So like you got negative, the negative is not on the inside of the parentheses. If it were, it would mess it up here. Now it might be if your x is a negative value, but it's not. It's positive 4.5. Type that in, we're going to get 10.25 So my vertex, or I could also call it a maximum. 4.5, 10.25. Okay, everybody with me here? All right. So, what I'm going to do, instead of doing these last two couple examples, I'm going to do a few from the worksheet because we're running a little low on time. I taught you something wrong. I'm going to make up for it by doing a few from the worksheet. All right, so let's look at -3. Number 3. Let's do number 3. Okay, so we've already found the y-intercept. It is 9. We find the x-intercept. It is -3/2, 0. Okay, so if I want to know the vertex, I can either do, so for my vertex, I can either do x equals -b over 2a, or I could look halfway between the x-intercepts. What do you notice about this particular problem? The x-intercept is all by itself. We only have 1, right? So since you only have 1, like when you factor this, you end up getting 2x plus 3 and 2x plus 3 whenever we don't have the work for, you might have the work written down. I don't have it written down here. So you end up getting 2 factors that are the same. So it's really like you get -3/2 and -3/2 for both x-intercepts. So you have 2, but they're the same. So what's the number halfway between -3/2 and -3/2? Not 1 because it is the same number, right? So what you're going to see if you only have one x-intercept, that is also your vertex. Okay? So if you only have one x-intercept, let's put this little note right there. If you only have one x-intercept, it is also your vertex. But if you, just to show you that it's the same, if I do -b over 2a, I will have -12 over 2 times 4, which is -12 over 8, which reduces to -3/2. All right. And then if I take -3/2, which it's going to be easier to plug into the calculator if I make that -1.5, if I plug it in, so if I do 4 times 1.5 squared plus 12 times 1.5 plus 9, so if I do it like I was doing the other problems, oh, I'm sorry. I've messed up. The x coordinate is the same. Good gracious, I need to quit right now. Right. Teach you guys something else wrong today. Yeah, who knows? Who knows?
Wait, so it's -3/2 and
The x coordinate is still the same. You know, that can't be right. Something's wrong here. What am I doing wrong? What did I do? Oh, I know what I did. What was my x? It was -3/2. What did I plug in? I plugged in +1.5. So I messed up. Okay, let's try this again. Okay, when I was trying, I didn't teach you anything wrong. I thought I was wrong. I'm second guessing myself. I'm about to. I'm gonna do a couple more problems and then I'm gonna let y'all take over. Okay, no, you cannot do that. All right, I'm definitely not putting Ian in charge. You'd let everybody leave. Yeah. Okay, it was -3/2. What I wrote right here is true. Ignore my mistake. Okay, so if you're going to graph this, first of all, is this going to be a smiley or sad? It's going to be a smiley. It is going to have a vertex at -3/2, 0, and x-intercept. And it is going to have a y-intercept at 0, 9, which is going to be a positive value here. Now, if we're trying to think like how we're going to make this work, if your x-intercept and your vertex are the same, if you just have that one x-intercept, this is what it looks like. It's going to come down here, hit that, and then go right back up. Okay? So it barely touches the x-axis, and then it goes right back up. That's what it would look like for this one. Okay. We need to do number 5 because you're going to have a hard time with those. You're going to have a little bit of you might have a hard time with the vertex on this. Let's do number 5, and then we'll let you do the rest of them. All right, so number 5. My vertex is x equals -b over 2a, but problem with this is, first of all, it's not in standard form, okay? If I put it in standard form, the x squared has to be first, so -x squared plus 1. What is my a value? -1. What's my b? It's not there, so it's a 0. It's a 0. Okay? So if you're missing the middle term, if you're missing that x, your b value is going to be 0. So you're going to have -0 over 2 times -1, which is just 0 over 2, which is 0. And if you think about the other thing I was telling you, your x-intercepts are 1 and -1. What number's halfway between 1 and -1? 0, right? And then so you're going to plug in 0. 1 minus 0 squared is going to give you the y, which is going to be 1. So you get 0, 1. Notice that it is the same as your y-intercept here. Your y-intercept ends up being the same as your vertex. So 0, 1, I could put like right here. And then I've got 1, 0 over here. And -1, 0 right here. And then, is this a sad face or a smiley face? Sad face. And it needs to be a sad face or you're going to have a hard time getting to fit those points, right? So this would be your sketch of your graph. Okay. All right, I'm going to quit right now before I teach you something else wrong today. I might. I could. There's a calculus way to find the vertex of that. But we won't. We won't take any derivatives today. All right. So, you got like 18 minutes. You need to finish this for your homework. So you're finding you should have already found the y-intercept and x-intercept, unless of course you were not here yesterday. So then you'll need to go back and do that part also. You're finding vertex and you're sketching me a graph for each one.